to express a quadratic expression in the computing the square format is just to change its form. A quadratic expression looks like ax squared plus bx plus c, where the coefficient of x squared is called a, the coefficient of x is given by the letter b, and the term without any x is called a c. The idea is to change the format into something that looks like this. Another constant, let me call the constant p, x plus another constant whole squared plus another constant. They're just different constants, and this format, the new format, is called completing the square format. So we call it completing the square form. Now it starts from the expression of a plus b whole square. When we write a plus b whole squared, we write, when we break it down, a squared plus twice ab plus b squared. It can also be a minus b whole squared, which is a squared minus twice ab plus b squared. Now the idea is, when we break this down, it looks something of a quadratic format, where the first one is a squared and the final one is b squared. So we want to change this into this. Or if there is a minus, we want to change this into this. So that's the main idea. Let's do an example. So suppose we have this one where we have x squared plus 8x minus 7. Now it is in the format of ax squared plus bx plus c. We want to express it as the complete square format. So if you write the first one as a squared plus, now this term, the second term, is going to be 2ab right over here. So we can write here 2, a is x. So whatever is left over is 4, because 4 2s are 8. So this is the b. Now this thing is done. Now what we want to do is add a b square. So plus 4 squared. This is something that was not in the previous line. So since we add it, for mathematically this line to be equal to this line, we have to cancel this again. Minus 4 squared. So that plus 4 squared and minus 4 squared cancels off. And then we write this thing. So if you notice, the first line and the second line is the same. This is x squared, this is x squared, this is 8x, this is 8x, 2 into x into 4. This is minus 7 and this is minus 7. And since this 2 cancels off, so this thing and this thing cancels off, so it doesn't really matter. So the first line and the second line is exactly the same. So when this happens, we can now actually write it as a plus b is 4, a plus b whole squared. If we use this, 3 terms, a squared plus 2ab plus b squared, we can write it as a plus b whole squared. Just like this one, we can use it and write it in this format. Now whatever is left over is minus 4 squared is 16, minus 7 is this. So we can write it as x plus 4 whole squared minus 23. That's the completing the square format. So here we have ax squared plus bx plus c. Here we have p, x plus q whole squared plus r. Let's do another example where we have a minus. So if you have x squared minus 6x plus 1. Now we have, the first one would be a squared minus, so this would be 2, a is already x. So in order to make it 6x, it has to be 3, so that it becomes 6x. Now plus b squared, if you take a look here, this is what we are doing. A squared is x squared minus 2ab. So b is 3. We need a plus b squared. So we can write here plus 3 squared. Then we have to write minus 3 squared so that this 2 cancels off, because the previous line and the next line has to match. That's why we write the equal to sign in an expression. And what is left over is plus 1. So let's check. So the first one is x squared. So we have x squared over here and x squared over here. This is minus 6x. So this is minus 2 3 is 6x. This also matches. This is plus 1 and this is plus 1. And this 3 squared and this 3 squared cancels each other out. So the previous line and this line is equal. So we can write a minus b whole squared, meaning x minus 3 whole squared. Because we can see that this particular portion, x squared minus 2x into 3 plus 3 squared is a squared minus 2ab plus b squared. So we can write it as x minus 3 whole squared. So what is left over is minus 3 squared, which is 9, minus 9, plus 1. So we can write x minus 3 whole squared minus 8. Now, if we were to break this down, these two expressions down, it would turn out to be the exact quadratic expression that we started with. Now, let's do an example where x squared is not free. So, in this example, if you have an example like 2x squared plus thrice x plus 1. Here, you have to notice, in order to make this x squared, we have to take 2 common, so it becomes x squared plus, now if you take 2 common from 3, it turns out to be 3 by 2, so that when you multiply it again, it becomes 3x plus 1 becomes half. So this is a bit more complex than the previous sums, which was more with integers. So let's start. So this one is going to be a squared plus 2a. b has to be such that 3 by 2 comes back, so we can write 3 by 4. So that this 2 and this 4 cancels out and we get 3 by 2. Then we have plus b squared, so b is 3 by 4 squared. We have to cancel this, minus b squared, meaning 3 by 4 squared, and whatever is left over is half. So now we can write a squared plus 2ab plus b squared is a plus b, which is 3 by 4 whole squared. And what is left over is 3 by 4 whole square, which is 9 by 16 plus half. So let's use the calculator now. So 2x plus 3 by 4 whole squared. Now let's write half minus 9 by 16. So half minus 9 by 16. So this is going to be minus 1 by 16. So we have minus 1 by 16. So now what we can do is multiply the 2 with this. So if you multiply the 2 with this, is 2 into x plus 3 by 4 whole squared, because we cannot multiply this because of the rule of PEMDAS. We cannot multiply this unless the exponent is broken down first. So this would be like that. Multiplied by 1 by 16 into 2 is 1 by 8. So this is it. This is the completing the square format. So we have changed ax squared plus bx plus c into the format of px plus q whole squared plus r. Now, completing the square format can be used to solve a quadratic equation also. So if you have a quadratic equation ax squared plus bx plus c equals to 0, we can solve this either by factoring, or we can solve this using quadratic formula. So the factoring is usually the middle term break. We can use factoring, middle term break, or we can use the quadratic formula. The quadratic formula is minus b plus minus root over b squared minus 4ac divided by twice a. So that's called the quadratic formula. Now another way of solving this question is the completing the square format. So we can convert this into a complete square. So completing the square form. So we can change any quadratic equation into the completing the square format, and we can do it. For example, if you have to solve this equation, if it was, let me go over here, if it was like that, x squared plus 8x minus 7 equals to 0, what we can do in the next line, we can write the complete square format, which is x plus 4 whole squared minus 23 equals to 0. Then in the next line we can write x plus 4 whole squared equals to 23. Therefore x plus 4 equals to, if the square goes to the other side, we can write plus minus square root of 23. And hence finally we can write x equals to minus 4 plus minus square root of 23. That means we can use completing the square format and find the root of that equation. Now another example would be the next one. Let me use over here. So if this equation was equal to 0, so if it was x squared minus 6x plus 1 equal to 0, In the next line, we can write the complete square format. So x minus 3 whole squared minus 8 equals to 0. So this would be x minus 3 whole squared equals to 8. Therefore, it would be x minus 3 plus minus square root of 8. And therefore, x equals to 3 plus minus square root of 8. And that is the root of the quadratic equation. So we can use completing the square to solve a quadratic equation. There is one more thing that can be done using completing the square, and that is we can find the maximum or minimum value of the expression. If there is an expression in the completing the square format p x plus q whole squared plus r, no matter what it is, this r is known as the minimum value of the entire expression. And the value of x when this occurs, that value of x is minus q. That means if we take a look at the previous sum that we just did, if you have this expression and the question is what is the minimum value of this entire expression, so in that case we have to look at the completing the square format, and minus 23 is the minimum value, whatever is outside the square. So the minus 23 is the minimum value of the entire expression, and the value of x when this occurs is x equals to minus 4. The same thing would be for the next expression. If you want to know what is the minimum value of this expression, then we can say that the minimum value of this expression is going to be minus 8. It's a coincidence, both here and here the minimum values are negative. It doesn't have to be negative. And at what value does this minimum value occur? It occurs when x equals to 3 plus 3. Whatever the value is inside the bracket, you have to reverse it as if this one is equal to 0. So that is the minimum value. Again, for the final example, for this expression, if you want to find the minimum value, of this expression, then look at the completing the square format, and the minimum value would be minus 1 by 8, and the value of x when this occurs would be minus 3 by 4. So that's the value when that happens. So we can use the completing the square format not only for solving the equation but also for finding the minimum value of that entire expression. Now one final thing, if the equation is a Cartesian equation, that means any equation that has both x and y variable in it, it would look like a picture. So this is a Cartesian equation of the quadratic polynomial. So it looks like this. We call it a parabola. So whenever we have a Cartesian equation of a quadratic polynomial, the shape is a parabola. So what we can do over here is we can change this into the completing the square format and write it as p x plus q whole squared plus r. In that case, what we can do for the parabola is know the turning point. The turning point is a special point of the parabola or any curve. So the y coordinate would be the r here, and the x coordinate would be minus q. So whenever we have a parabola, the Cartesian quadratic polynomial equation, for that we can find the turning point using the completing the square format.